this video, let us see something about non-destructive testing. In this modern technology, we are using varieties and good number of materials for a system in different fields, such as power plants, machines, tools, transport machines, chemical industries, and so on. So before going to use such kind of materials, we have to check the condition of the material, whether the material is in good condition or in bad condition, or it is condition means it may have some flaws in it. We have to identify that. So to test that, we have two kind of testings. One is destructive testing and another one is non-destructive testing. So in destructive testing, we can test the samples, but after completing the testing, we cannot use that material. While in the case of non-destructive testing, after testing, we can use the material, which will not damage the material. So that only in the name itself we have non-destructive testing. Okay. The difference between the destructive and non-destructive testing is, in destructive the method is applied only to a sample, but in the case of non-destructive testing, it is directly on product items or production items. That's the first point. Next, in destructive testing, tested parts are damaged during testing, means we cannot use after that. But in the case of non-destructive testing, tested parts are not damaged while testing. Next difference is, different tests cannot be performed on the same item. But in the case of non-destructive testing, different tests can be performed on the same item. Next important point is, in destructive testing, preparation of testing specimen is often required. But in the case of non-destructive testing, no specimen preparation is required like destructive testing. The next point is, it cannot be performed even to a single part that are in service. But in the case of non-destructive testing, it can be performed on various parts that are in service. One important point in destructive testing, the time consumption to test is very high in that. But in the case of non-destructive testing, we can check the product quickly. The time consumption is very low compared to destructive testing. These are all the differences between destructive and non-destructive testing. Generally, entity testing is commonly employed in shipbuilding, manufacturing of aerospace vehicles, automobiles, metals manufacturing, electric power plant construction and maintenance, and so on. There are 7 methods available to check the condition of the material by using entity: visual inspection method, liquid penetration method, ultrasonic flaw detection technique, radiographic technique, eddy current test, magnetic particle testing, and thermography. So of these methods, let us discuss the pulse echo method only in this video. So the pulse echo method is coming under the category of ultrasonic testing method. There are 3 types of testing methods in ultrasonic testing. First one is pulse echo, and the second one is through transmission method, and the third one is normal beam and angle beam method. And generally we do not use contact and immersion method. So among these 3 methods, the pulse echo method is the effective one because it can find the flaws in a correct manner, and it can locate where the flaw is exactly. principle of pulse echo system method is whenever there is a change in medium, then the ultrasonic waves will be reflected. This is the principle used in ultrasonic flaw detector. Thus, from the intensity of the reflected echoes, the flaws are detected without destroying the material, and hence this method is shown as a non-destructive testing method. So now let us see the pulse echo testing method in detail. But first let us see the construction. So it consists of a piezoelectric transducer coupled to the upper surface of the specimen without any air gap between the specimen and the transducer. The pulse generator is connected to the transducer to produce ultrasonics, and the same is also connected to the CRO in order to record the transmitted pulse as shown here. An amplifier is connected in between the transducer receiver and the CRO in order to amplify the received signals. In CRO, the timing section helps to note the time interval between the transmitted and received signals. Let's see the working. Consider there is some flaw in the specimen. The pulse generator generates high frequency waves, and it is applied to the piezoelectric transducer, and the same is recorded in the CRO. Name it as pulse A. It is for our reference value. Then the piezoelectric signals are resonated to produce ultrasonic waves. These ultrasonic waves are transmitted through the specimen. It is moving entirely. These waves travel through the specimen and it is reflected back by the other end. The reflected ultrasonics are received by the transducer and is converted into electrical signals. These reflected signals are amplified and is recorded in the CRO, and name it as pulse B. If the height of pulse A and pulse B are almost same, and in between the two pulses we do not find any pulses, the material is in good condition. While checking in between pulse A and pulse B, if we have some more pulse, we can come to know the material is having some flaw in it. Say for example, if the reflected pulse B is same that of the transmitted pulse, already we have given and named it as pulse A, then it indicates that there is no defect in the specimen. On the other hand, if there is any defect on the specimen like a small hole or pores, then ultrasonics will be reflected by the holes. Because we know the principle, whenever there is a change in medium, then the ultrasonics will be reflected back. So the defects due to change in medium, these defects give rise to another signal and name it as pulse Z. In between pulses A and B, it will occur. Similarly, if we have many such holes, many Z pulses will be seen over the screen. We can see that in CRO. From the time delay between the transmitted and the received pulses, the position of the hole can be found. And So in this procedure we can identify whether the material is having some flaws in it or not. So compared to all other methods, this is the effective method in ultrasonic testing method. So let us go to the advantages of this method. It can reveal internal defects. This method is highly sensitive to most of the cracks and flaws. It gives immediate result at very low cost and at a very high speed. And this method, it indicates the size and location of the flaws exactly. As we have seen already, from the height of the Z pulse we can identify the depth of the flaw. Between A and the Z pulse we can find the distance between the material and, or we can locate the flaw. Since there is no radiation in this process, it is a safest method among the other methods. This method is also having some limitations in it. First one is, it is difficult to find the defect